Hello, mathematicians. Today we're going to be learning about whole numbers, more specifically how to find the prime factorization of a number using the ladder method. Before we get started, let's go over what prime numbers are. So a prime number is a number with two factors, and those factors are 1 and itself. So some examples include 2, 3, 5, 7, 11, 13, 17, and those numbers keep going. So these are examples of prime numbers because their only factors are 1 and their selves. So for example, 3 is a prime number because only 1 times 3 is equal to 3. So 1 and itself, just like the rest of these examples. Alright, so to get us started, we're going to use the number 180 as an example. Alright, and basically for the ladder method, we're going to take 180 and divide it by multiple prime numbers until we get 1 in the bottom. So we're going to use a sign that looks like an inverse division sign, and we're going to think of prime numbers that would go into 180. So for example, 2 is a prime number and it goes into 180. So what we're going to do here is we're going to do 180 divided by 2, and we're going to get 90, all right? So because 90 is a composite number and it's not prime, we're going to keep going until we get 1, all right? So a prime number that goes into 90 is 2. So we're going to take 90 and divide it by 2. 90 divided by 2 is 45. And now 45 is composite, so we're going to keep going. And a number that's prime that goes into 45 is 5, all right? And 45 divided by 5 is equal to 9. And then be mindful that 5 is not the only prime number that does go into 45. We're just picking prime numbers that do go into them. There could be different ones, okay? And so now that we have 9, a prime number that goes into 9 is 3. So 9 divided by 3 is equal to 3. And so what we're going to do is we're going to divide until we get 1, all right? So 3 is a prime number, so the only number that goes into 3 is 1 and itself. So 3 divided by 3 is 1, all right? Once we keep dividing and we get to 1, that's how we know when to stop, all right? So if you notice all our numbers to the side here, they're all prime numbers, and this is our prime factorization of 180. We're going to take these numbers and write them in order from least to greatest. So our prime factorization of 180 is 2 times 2 times 3 times 3 times 5. If we multiplied these numbers on the bottom, we would get 180, and that's a way that we could do to check our answer. All right? So let's use 180, but this time start with a different prime number to see if we get the same answer. So instead of starting off with 2, another prime number that we could have used is 5. Now this isn't the only prime number. We could have used 3 if we wanted to, but nonetheless it is prime. So 180 divided by 5 is equal to 36. Now we're going to take this 36 and divide it by another prime number, all right? So prime number that goes into 36 is 3. Now it's not the only prime number that goes into 36, but it's one of them, all right? So 36 divided by 3 is 12. And now we're going to divide this by another prime number because 12 is a composite number and we have to stop at 1, all right? 12 divided by 2 is equal to 6. And now we're going to take 6 and divide it by another prime number. 6 divided by 3 is equal to 2. Now 2 is a prime number, but we're going to keep going until we get 1. So 2 divided by 2 is equal to 1. And now we take these numbers on the side and we write out our prime factorization. So we did end up with the same answer. Prime factorization of 180 is 2 times 2 times 3 times 3 times 5. Now be mindful that we don't include the 1 because 1 is not a prime number. The only factors of 1 is 1, and that's it. A prime number is a number that has 2 factors, which are 1 and itself. All right? Now let's do another example where we use a different number. So we're going to use 210. And be mindful that we could use multiple prime numbers to start us off, but we're going to take the 210 and divide it by 2. So 2 goes into 210 105 times. And now we're going to keep going until we get 1. So 105 can be divided by 3. So 105 divided by 3 is 35, all right? And 35 is still a composite number, and be mindful we have to stop at 1. So 35 divided by 7 is 5. Now 5 is a prime number, but just be mindful that we do have to stop at 1, all right? So 5 divided by 5 is equal to 1. So here we have our prime factorization. And remember that for prime factorization, we always have to write them in order from least to greatest. So our prime factorization of 210 is 2 times 3 times 5 times 7. And that's it, we're done, all right? Now let's take the 210 and just show that we could start off with a different prime number and still get the same answer. So a different prime number that we could have started off with is 5. 210 divided by 5 is equal to 42, all right? And then we're going to take the 42 and divide it by another prime number, and a prime number that goes into 42 is 2. 42 divided by 2 is equal to 21, all right? We're going to take the 21 and divide it by a prime number, and we could divide it by 7. So 21 divided by 7 is equal to 3. And now we're going to take the 3 and divide it by itself because 3 is prime. And remember that we have to end up with 1, all right? We don't include 1 in the prime factorization because 1 is not prime, but we take these numbers that are off to the side. So the prime factorization of 210 is 2 times 3 times 5 times 7, and we ended up with the same answer. So that's how we find the prime factorization using the ladder method.